Okay. Well, that was exciting. All right, let's go over here. And turn that off. And we're golden. All right. So there was a quick moment of panic there. Hopin didn't like it anyway. So hi guys, welcome. Um, this is our first build workshop. This is the one in tinkercad. Is everybody about where I am in tinkercad? That is, they're open, they're ready to go. Okay, so since this is recorded and we only have an hour, I'm just going to, oh, hi, Mary. Yes, okay, good. All right, so I'm just going to go ahead and continue on. So if everybody's logged in, we're going to go ahead and create a new circuit. And then we wait. And then if everybody wants to come over here on the right, we have some starters. We'll select Arduino. And a lot of the work is going to be done for us already if we just drag the breadboard over. There it is. Yay. All right. And so now we're going to go back to our basic components. And we'll wait and we'll wait. And just a quick note that if you don't like what tinkercad picked for your project, you can actually change it. If I could type. Go. All right, so let's place our resistors first. And so we just drag one over. And by default, it's going to give you a 1K resistor. Well, that's a little much for our LEDs. So we're going to change this symbol to just an ohm. And then we're going to change the resistance to 220. And you'll see that the bands changed to brown, red, red. And that's good. And then before we place these on the breadboard, we're going to Control C, Control V, until we have 7 of them. 6, 7. Okay. And so what we want for our resistors is we want the top leg up here. This is referred to as the negative or ground rail. And you can see there's one on each side of the breadboard. So let's just add these in on the top, evenly spaced. Whoop. Grab the workbench, not the resistor. That happens. All right. All right, and then we'll just give it a minute here, make sure that everybody is at the same place. All right. So, and just a couple of other quick notes in case you're not quite, just to make sure I give enough time for everybody to be done. You can use your mouse wheel to zoom in and zoom out. And if you click and drag on any of the white space, it's going to move your project around. And if there's any other questions, put them in the chat and I will try to answer them over the air. All right. So hopefully everybody's got all their resistors in place. If not, I will make this project public. So if you mess something up or it's just something's not quite right, this will be a public project so you can come. I haven't done any wiring yet, Mary. We're just on the resistors. It's okay. But anyway, I am going to make this project public so that if you don't quite get everything done in time for tomorrow's major coding session using tinkercad, you can make a copy of this project. So next we're going to do the same thing for our LEDs. And we'll grab 1, 2, 3, 4, 5, 6, 7. Now, let's see, where's number 1? Okay, so number 1, we're going to leave red. And if I remember right, we do it. So we want the bent leg in the same column here as the resistor. And now the next 2, we're going to actually make these yellow. And let's make sure that we've got number 2, because if we don't have number 2, it's going to affect the code. Let's see, 4, 3, there we go. And we'll make this guy yellow. And now let's find number 4 and make him green. And number 5 should be green as well. And number 6 is blue. Drag him over. And number 7 is blue. All right. And so we'll give it a minute here. Just to make sure that everybody's caught up. Yes, Meadow, I would love to answer your question. You know, I've never tried it that way, but we could try it quick. So if I have 2 LEDs and whoop, and no, because there's no way to select multiples. Oh, there we go. So not really. You can select 2 things and move them in a group, but as far as changing their attributes, you have to do that individually. And that goes bye-bye, and that goes bye-bye. All right, good question. All right, so now we're going to wire this up. And so what we're going to do, and this is a good practice for any Arduino project, on every board there's going to be these 2 pins, 0 and 1, and see how they're marked TX and RX? And so those are the same pins, send and receive, that will work with the USB port. So if at all possible, we always want to leave these guys open. If you absolutely have to use them, that's okay. You're going to need to put the code on your board first and then hook them up. So just a word of caution. So that's why with our red LED, we're going to go from this pin here, and then we're going to make the wire match the setting or match the LED. And then we're just going to continue on 2 into 2. And yellow to yellow, other yellow to other yellow. And thankfully greens don't need to get changed because, hey, they're already that color. And there's our blues. And here's our other blue. All right. So now we're down to one last thing. We'll go ahead and give everybody a minute or a moment or whatever to catch up. And looking at the chat here. Yeah, John, that's smart. We don't do smart in the soldering village. We do what we know because we're nervous and have not consumed as much alcohol as we would have had this been in Vegas. All right, so the final thing we need here is a push button. And so there it is. It's a push button. It goes clicky, clicky. Now, push buttons on an Arduino, they're a little different. They do require some additional hardware to make them work right. So we're going to start by putting our push button here at the end of the board. Then we're going to take a wire and go from here and into the positive rail. And we're going to make that pink because we already used red up here. And now we're going to take another resistor. Isn't it pretty? All right, and this time we're just going to add a 0 and make it a 10K ohm resistor. And this goes into the negative rail. And now we have to get the button to talk to the Arduino, which leaves one last wire, which is going to come from way up here and cross over everything. And what input did I put that in? It looks like 10. Okay, it's in 10. And then just to keep things organized. So a quick note on the wires while you guys I'll make sure everybody's finished up here, is that at some point, if you really want to, you can click and they will bend. If you need them to. Honestly, yeah, I don't. I don't think I need to feel the need to feel that fancy, but if you want to, go ahead. You can also drag your wires, or at least you used to be able to. Apparently you can't anymore. Woohoo! Thank you for changes, Tinkercad. All right, so now that we've got everything hooked up, and as you can see it, we're going to go ahead and click Start Simulation. And the only thing that's going to happen right now when you do that is that this little guy is going to blink. Arduinos come pre-programmed. They're going to be running a little sketch. That's what they call the firmware in the Arduino world, is it's a sketch. And so the sketch that's loaded on in the beginning is this blink sketch. And it's just going to take the internal LED and go blink, blink, blink. Well, that's kind of boring. So we're going to go ahead and we're going to play around with the blocks because blocks are fun. So let's get everything tested here with the blocks. Does anybody need any more build time first before we really get into the blocks and make sure that we've got everything hooked up? Oh, the ground and wire. That was actually, if you go up here to components and hit Arduino starters, we just dragged one of these over. The first set of resistors are 220 ohm, Lisa. And then the resistor on the button is 10K. All right, it sounds like Lisa and Mary could use a few more minutes, so we'll go ahead and give them that because I horribly misjudged, even with talking about the things as I did them, how long this was going to take and scheduled this for a full hour. So yay, more time with the blocks. All right, I'm going to initiate what's called a ready check if you've ever played World of Warcraft or other multi-MMO or MMORPG. So if y'all could give me an R or ready in the chat, we'll move on. All right, so right now we could have done this up to here. We could have done this project with pretty much anything. What really makes this the simulator, obviously, is the ability to add code. Now there's two different ways that Tinkercad will handle code. They have these beginner-friendly blocks, and then we also have, we can do blocks in text or straight text. Tomorrow's session will be the straight text that lines up with the code that'll go on the physical boards from the other two sessions. But for right now, we're just going to have some fun. And we're just going to use the blocks because they're easy and simple. So if we take this is the built-in code for the Arduino, and we're just going to go ahead and get rid of all of that because we don't need it. We don't want it. It apparently doesn't want to go away. It's offended. How dare we throw away its original code? There we go. All right. So much like you'll see tomorrow with the actual text, we're going to use these codes, these blocks here, and we can set these now by pin. So if we set pin 2 to high and start simulation, that should have turned on, and No, it blinked and went off. Why did that? Interesting. So now let's try that. So we've taken the red wire and said, hey, turn on for a second and then turn off. Turn on, wait a second, turn off. And then because they're very verbose, we need to have it off for a second as well. And now hopefully, yeah, it blinked. It blinked and stopped. All right. Where do I have these back? All right, so that's that. And you can go ahead and be as crazy as you like with these. We can actually go back and turn a couple more on here too. So let's add a yellow one. Should be about pin 4. And we'll add a blue one on pin 8. And then we'll snag some more down here. Oops. And I grabbed the wrong block. And so if you need to get rid of something, just pull it apart, kind of like Legos. You know, I think they are. Ah, very good. Okay. So I messed up because I'm nervous and haven't um, done any really new projects where I felt the need to simulate it out first. So I do believe he's right. Let's take a look. So if we move that over, and we'll set these to 2, and we'll set this one to 8. No, I was right before. Weird. Okay. So my Tinkercad's being a little weird. Sorry about that. I did test this, but unfortunately I tested it on my Mac probably a week ago, and that's always the trouble with online tools, is that they can make little changes and not tell you about them. And now it's working. Who knew? Weird. Oh, yeah. Oh, good God. Oh, I am totally off here. Okay, well. Fascinating. Okay. So yes. So I did actually screw these up, and I'm going to fix them here quick. You should have been on the ground rail, not the positive rail, and that's why we're having trouble, and that's why I'm having trouble with the code. Hopefully you listened to my words and not followed the screen. Woohoo! Come on. All right. Let's try this again. And don't start with me. I love live demos. I really do. All right, so let's move this over. The demo gods are not being kind to me. And so we're just going to move these over one. Because apparently, yes, my... Stop it. Go away. Sorry about this, guys. Yeah, I don't have a lot of practice streaming, and I'm much funnier in person. Just saying. All right. Stop that. Yes. Oh, come on. Fine. Bye. All right. Now that we have this wire selected, we can actually move it. Yay. All right. No, I'll be done here in a minute, and we've still got another half hour. So, yeah. I do apologize for this. It did not help that there was thunder and lightning, and I've been up since about 5:30 my time, and it's now 11 a.m. my time. So, yay. All right, so we're almost fixed here. Because apparently in between my sessions, I'm going to have to run to a Starbucks. All right. There we go. Now let's start that again. Oh, look. Yay. Yes, but see, I live in southern Canada, aka Minnesota. We apologize for everything. Okay, so now that we've shot my circuit and determined that, yes, I need more coffee, we can play with the blocks some more. Okay, so we've got 2, 4, and 8 set on high. We're waiting a second, and 2 and 8 are going low. Why is... Stop it. And so these are the blocks. And so you can actually, yeah, got that working. Yay. Let's set, and we'll drop 4 into low as well. So now they all go blinky blink. So, woohoo. Now we're going to go ahead and we're going to trash these blocks. And we're going to work on, and we're going to show you the button block here. Maybe. All right. So oh, if I look for what we need here. All right. think I've got all my bits here. So to use a button or any kind of input on an Arduino, we need to make the code ask a question. So if the thing happens, then what? So to do that, we need a math block. And so we're going to say to read the digital pin. And our digital pin for this exercise is number 10. And if it's high, if it's on or pressed, it'll do something. If it's low or not pressed, and that may be backwards. Like I said, under caffeinated. We'll fix that for the next session. And then we stick that in there, and we've got basically an if statement, same as in a regular code. So then we need to make sure that if it does something, so let's turn on our friendly blue LED. It seems to like me better. I don't know why. We pop that in there and hit here. And there's our button. And then we'll follow that up with, and then we're going to make it a little more complex because it read it, it said it was high, turn the light on, but we want it to do both. So we're going to move our little math block to here. We're going to grab high to there. And then we'll take this one and set it to low. And we'll trash those standard if statements. Why are you doing this? And so now the LED only lights up when we click on the button. Yay. All right, anybody have any questions or comments or anything else? Let's see. I know they are all being recorded. I think they're going to pop the recording into the sessions as pre-recorded sessions. I know I have said that I will have that my sessions, because every session for Hop In is being recorded, that yes, it was okay to make my sessions public. So to be honest, I'm not 100% sure because well, it's okay, Mary. It's okay. You've got time. There's always the homework. Is there anything we need to know if we're doing the soldering version? The soldering version is pretty much going to run the same way. We'll be doing these things in the same order. There's nothing that's covered in here other than, you know, showing you the basics of the blocks of how to, the basics of the blocks that's in the soldering version. I can't really think of anything offhand. Just make sure you have your equipment and ready to go. Why, yes, Ben, I know you know this answer and are anyway, so Ben asked if to care to explain the difference between a current limiting resistor for the LEDs versus the pull-up, pull-down resistors used on the switches. So I did kind of gloss over that. So basically, we have the two LEDs on this circuit are doing two different things. The top circuit, the ones here, here are limiting the amount of current that can go into the LED. So, for example, most of these LEDs run between 2.2 and 3 volts. And the output here here on an Uno is 5, if I remember correctly. So we need to basically cut that down so that we don't burn out our LED. Whereas here, these little switches can be kind of noisy. And so this is actually a pull-up resistor so that when the switch is open, there's no noise going back to pin 10, triggering a false press. And then John asked, if I run the simulation, the red turns on the whole time. Is that because it is in line with the switch? Yes, it is. So let's move that part of the circuit over as soon as we stop the simulation. So we'll just bump this one guy over, bump this one over. And if we bump this one over and hit start, now we just get the blue light. All right, who else has questions, comments, concerns? All right. And the neat thing about this is that we can stick with the blocks. It will actually, if I remember to do this right, stop, there we go. It will actually convert your blocks to code. So everything that we did as far as saying, hey, we need pin 8, the blue LED as output, pin mode 10. 10 is our button, it's set to input. This is the infinite loop of an Arduino sketch. So it's saying that if pin 10 is high, then turn on the blue LED, which is on pin 8. Otherwise, leave it off. And then it's even kind enough to add the little bit of debuffing we need to make sure it's improving the simulation performance. It's also a good practice in real code, just so that it stays either high or low the whole time. And you do want to be careful because if you go to straight text, it will not let you edit your blocks anymore. They'll be gone. And another fun feature is that on the simulator, the serial monitor works. And if you're taking some of the other sessions, one of the things that is handy about an Arduino is that we can set up the serial monitor. So at different points during your sketch, if you want to check that it's reached that point, you can print something to the serial monitor. If you're using a sensor and want to see the data, but maybe not have an LED or a motor or whatever react, you can show that it's triggered with the serial monitor. And so we're going to trigger our serial monitor with just hello world every time the button's pressed. And you can see multiples because it's going through, as it goes through the loop, the button is going faster, or the loop is going faster than the actual button. So so even in real life, you might see more than one hello world. So let's see, what else we got? All right, so there is about 20 minutes left in this session. Does anybody have any questions, comments, other pieces or parts bits that you might want to see virtually before you try using them in real life. Yeah, I will admit that for some projects, I actually still like to start here because I can kind of get my idea out of my head very quickly. So yeah, this is kind of a really nice free tool from Autodesk. Okay, Kelly, and I'm going to read your question because recording. Could you go over the basic rules of how to build these circuits and maybe where to go to learn more? Thanks. Okay. So it's kind of the same question, two different ways. Probably the best place to go, ARD Arduino.cc. So probably the best place to start is actually the Arduino homepage. And they do have, you can code online with the web upper. They've got all the different things. Libraries, course, troubleshooting. You know, they've got lots and lots of tutorials on getting started. Another good place to go, I find, is one, YouTube, just start searching. And two, I learned a lot of my basic stuff. I went and bought a kit, like an Arduino kit, where it had the Arduino and it had some LEDs and resistors and diodes and a couple of little tiny servos. And then it had a nice little booklet that kind of explained the basics. I don't remember, I think SparkFun. Still throws out some good tutorials as well here. Let's see. Shop, learn. So SparkFun has lots and lots of tutorials. Another good place to go get tutorials is at a Fruit Industries. Yay. Thank you, Google. And so they also have a good learning section. Pretty much if I can't remember how to do something, I go to Adafruit because she will probably have a guide for it, and she's got some really good guides as well. Especially if you get more into the more advanced programming. She's got a really good 2 parts thing on multitasking. I mentioned homework. Okay. Homework is to make sure that this guy matches up, that your version of this board matches up. Otherwise, I can hit the share button here. Otherwise, I can share it for later. So really that's your homework, is to make sure you're done, you've got everything set up, and to try the blocks. And so I'm just going to put these links here in the chat, if you want to check them out. So yeah, no, for homework, I expect you all to go to arduinos.cc/ing/tutorial/foundations and read all of the links. No, I'm kidding. I'm kidding. All right, anybody got any other questions, comments, or concerns? Did I share my project? What I have to do is I have to go back out. I remember how to do this, right? And let's see, where is it setting? Private, tinker this, comment. Oh, where is it? Cancel. That's not what we wanted. There is a setting that makes this public. And let's try the gear. Design name. Ah, there we go. Privacy, public, save changes. There. So now you can look at mine. You can just copy mine to your own account, however you want to do it. Like that one. All right. And let's go back. All right. So there's about 10 minutes left in the session. So last call for questions, comments, concerns. Well, thank you for attending, Mary. The wiring is now correct for the red LED. That was my bad. When we moved it over, we started sharing with the switch, which was why it was on all the time. And just like in real life, you're always a little nervous first session of the day, and I didn't catch it. Oh, it does. It does. Thank you, Meadow. Ah, get over there. There we go. Alrighty then. I don't forget to sign up for the raffle. I think if you attended this session, you were in a drawing for a beach towel. Remember that there are two more physical sessions today, and then we will be exploring the proper code-based, the proper text code-based programming tomorrow. So I really do want to appreciate y'all. Thank you for bearing with me on my first session of the day. And thanks for attending. I'm going to go ahead and leave this session so I can get ready for the next one. Any other questions or comments, go ahead. My Twitter is at TechGirlMN. Otherwise, I have no problem with you guys using my Diana Initiative email address, which is chris@dianainitiative.org. If you have further questions or comments, don't ask me. It might take me a while to respond. I've got 2 more sessions today, and then of course the 2 sessions tomorrow. But next week, if you have an additional question, comment, concern, whatever, feel free to reach out to me. And I do want to thank you all for attending. And y'all have a good day, and I'll probably see you again. All right. Thank you.